Good morning, everyone. Natalie and Dominique, can you hear me? They're probably muted.
Yeah, they might be muted.
They're good. Okay, great. Thanks, Ed. All right, welcome everyone to Sean's dissertation defense, which I'm quite excited about, and I'm sure he is as well. Just as a little background, so Sean graduated from Cornell College in Mount Vernon, Iowa in 2012 with a joint degree in computer and physics and a minor in chemistry. So he's clearly been, an overachiever since before he got here. He joined the U in and joined my group with the first batch of students. So Sean's been going on this journey with me for the last 5-6 years. Since coming to the U, Sean has done quite a bit of things besides just his research. He TA'd several times, including twice for the Viz course and once with me for an undergrad, our second semester program. I think most grad students at all want to do, and he four journal pubs, including publications at InfoViz and Euroviz, and two conference papers, and one more paper in progress. Them, and they're given out each year to the top incoming graduate students.
Excuse me, guys. We can't hear you anymore.
Oh, your microphone.
Yeah, I don't know if the battery needs to be replaced or... It's going to be a very quiet
Okay, can you hear me now? There we go. Okay, sorry. Can you hear me now?
Yes.
Okay, great. Anyway, I was just wrapping up. So that's a little bit of context for Sean. I'd also like to thank his committee for being here. It's Jim McGutter, who is professor in the College of Architecture in the design program, Tammy Denning in School of Computing, Alex Lex in School of Computing, and then his external committee member, Natalie at Microsoft Research. You can hear her voice over the speakers.
Yes, I'm here.
Great, so thank you guys all for joining. Thanks for everyone else for being here. And Sean, I will turn this over to you.
All right. Thanks so much for the very nice words, Mariah. Appreciate it. And so I'm here to tell you guys a little bit about what I've been working on the past 5 years from all of my experience in visualization design. And throughout this time, my dissertation is focused on the design theory framework. And we're going to go into that. But I first want to, answer a simple question about, what is visualization design? And it's about this process, about how you create data visualizations. You take a data visualization, it could be a single one, or it might be a bunch of different visualizations working together in tandem for a software system. You use them in user interfaces or build them into tools. And throughout this process, you work with users where you take ideas that you have to try and solve their different problems. You identify those needs that they have and figure out how you can come up with maybe like sketches, ideas to then solve some of the issues they might be having within their workflows and day-to-day lives. And then from there, we want to take these ideas and think about how we can evolve them. Maybe take some ideas, bring them together, put them into new ideas that come out of different ones, as well as build systems to address those ideas. And from here, we want to then take these ideas, figure out how we can plan and create this whole design process and add the details to solutions like this so that real users can use this in their day-to-day lives so that they can make the world a better place by using data visualization. So we need to create these things for them. And so I'm first going to walk you through one of the domains that I've worked in, specifically cybersecurity, to kind of understand why data visualization design is critical and important for this space. And so the motivating example here is, everyone here probably has some smartphone sitting in their pocket, right? And it might have all sorts of information on there. You might have your location data, you might have financial, like credit card information. You might have like some personal information on there as well that you don't want other people to know, maybe your passwords. As well as, we have businesses, a lot of computers out there, corporations that have trade secrets, intellectual property, and services that you maybe use all the time, whether it's Google Drive or Dropbox. And these are often, something that are connected all the time, and that also means that they're at risk, or you might have some hackers coming stealthily in the night to steal your electronic livelihoods. And I jest here a little bit, but only slightly, because there are real hackers out there. They try and make money off of you. They try and sway your national elections. There's a lot of impact that these sorts of things have. So it's important that we have secure networks and secure these sorts of systems in our data. And we can do that with the help of data visualization. And so who helps protect these types of systems? So we have these cyber analysts that work to protect our data, to find what's going on in the real world and try and keep these bad things from happening. And so these cyber analysts trying to discover and find traces and adapt the defenses of our networks over time. But there's significant challenges in working in this design space when trying to create data visualizations for these analysts. The first of which is that these attackers, they aren't just using the same methods over and over again. They're trying to find new ways to break into our networks, to find ways to, maybe there's a new type of exploit that they want to take advantage of. And in addition to that, there's also a large amount of data within this space. As we have more and more systems, we have more and more data that is being recorded about those systems. And as that importance of that data arises, then also we have stronger defenses that might collect more data. And in addition, it's often the details that are really critical for the cybersecurity type of information, where people really care about not just an overview visualization, but they want to be able to look up the details as well. And there's some mistrust analysts have for visualization. And then lastly, some other challenges are that sometimes we don't always have all of the information. There might be some missing information for this problem. As well as we have limited access sometimes to the users and the data sets for these problems, because these analysts are very busy trying to keep our network secure all the time. So how can we overcome some of these and create successful visualizations to help these analysts solve these problems and keep our network safe? And so we explored this domain specifically when we conducted a redesign project, trying to come up with, worked with a cybersecurity firm to redesign their large software tool. We came up with sort of this mock-up you see here on the screen. And this team that originally worked on this project, it was a mixture of research and design expertise. Jim as well, who's here in the room, and Mariah, myself, and some other folks, a psychologist and some other designers that we worked with throughout this process. And what we found is that there was a bit of a mismatch in our process, like how we mapped visualization design models to how the designers worked. And we tried using existing models to go through this process, but they didn't guide us the whole way. We hit several roadblocks, so we couldn't quite use those models just as they were. And so, again, when using these models, we faced several questions that we were unable to answer. And so some of these questions include things like, what am I trying to create? A very, very simple question, like what is the goal of our process? What are we trying to work towards? And with each of these questions, we also had a unique goal that we identified, something that if we had a new model, what could we do with it? And so we could also have one that could be more achievable by identifying what we should create, what we should work towards. The next question was, how do I compare and select these different outcomes? And so here, this leads to a goal that's maybe, how can we be more justifiable, sort of connecting the actions that we take and the decisions we make. The next question is about what actions can I perform during a visualization design process? So here we might think about what are the different methods and techniques that we have, and how can we make them more discoverable so that you can maybe find new types of methods that we haven't used before. And then where should we go to next? Like after we finished one of these artifacts that we've achieved, like what should we do after that? And this is a question we had sort of like, how can we capture this flexible nature of design? As you go from one activity, maybe you go backwards, and how you can maybe sort of model this iterative and complex nature. And then lastly, what are the steps that I should perform during the design process? Sort of like more of a detailed walkthrough. And this led to like, how can we make a model more actionable to provide some of the step-by-step? And in total, all of these questions and these goals, if we could meet this with a model, it would be something that would provide a richer description of the design process. So during this redesign project that I just mentioned, we created a new model for this. So I present now the primary contribution of my dissertation, which is the design activity framework. And the design activity framework is a data visualization design process model that was designed to help guide and support the creation of visualization, like data visualization interfaces, where you might build tools and systems. And the goal here is to make them effective and usable and useful. so we can work with users and find out what their needs are and make good tools as a result. And we also wanted to be able to describe and capture some of this design flexibility and all those other goals that I just mentioned, making it more achievable and actionable. And so specifically, the design theory framework is composed of the following components. The first of which are visualization artifacts, things that you try and are your clear goal for a design process, what you're trying to achieve and track your outcomes. And I'll represent them, as you'll see throughout the slides, in this little orange circle. And then we also have a mapping to design decisions to make the model more justifiable by trying to understand, what's your rationale and how can we justify a design. In addition, we created a table of design methods to sort of promote this discovery to finding new types of generative and evaluative methods to create artifacts. And then we have design timelines, which were designed to help support the communication of a complex design process. And then lastly, we created activity worksheets to help outline the steps and provide a more actionable approach to do visualization design. So in addition to these components for sort of this primary contribution of this design theory framework, we also formulated the framework out of a series of projects. Some of which were formative, like I mentioned, the redesign project, where we actually took our knowledge that we gained during that design process, working with other types of designers, and created the design theory framework, but also summative projects, where we took the framework and applied it in the real world. And so there were some validations that we had, where one of those projects that we applied, we did sort of an external validation using a design study, where we created a dashboard. And then we also did that was an internal validation. There was also an external validation where we worked with other types of novice users, students in the classroom, to see if they can use the design activity framework to create their own systems. And lastly, we reflected on other types of research projects, specifically technique-driven and evaluation-type research, to see, are we able to use the design theory framework to get new insights and make connections to the visualization design process. So during this formative redesign project, we created the design theory framework, and we tried to use existing models for visualization design, one of which is the 9-stage framework. And this is a design process to try and model for doing visualization design studies, where visualization experts work to create visualization systems that support solving a domain collaborator's real-world problem. And so this 9-stage framework is very useful because it captures a variety of different phases of the design process, everything from planning stages to reflection stages. But what we found was that there were some missing aspects when we were going through doing our own design process. Things like there was a limitation because it was more focused on design studies rather than general problem-driven visualization design. And then it didn't list things like having achievable artifacts or more discoverable methods. And this also walks through like how we can maybe, how do we conduct a design study, but how can we actually connect our actions that we've taken with the decisions we've made? And so there's another design model in the field that's well known, which is the nested model. And here this model captures the visualization design decisions you might make at 4 different levels. And so these different levels like domain characterization, the data abstraction, and coding and interaction design, all these interact with each other in such a way that decisions cascade. So an example of that would be if you come up with some new way to encode map-based data, like for cybersecurity. If there's actually no need for that, if the users don't care or don't get any insight out of map-based encodings, then you've kind of wasted your time because it's not going to help them solve their problem. So you have to be careful about making decisions too far inside of this model without justifying them. And so a design model allows you to capture sort of your rationale in the moment about why you've done something, but then also to record like maybe comparing different decisions about sort of the what you've done. So that what and the why are important parts of a decision model. And it helps you choose appropriate validation techniques to know how you should compare 2 different types of encodings or 2 different algorithms. A common use case might be comparing just the big O running time of an algorithm. And then lastly, these decision models help support knowledge transference, where you might want to take your rationale and apply it to a similar problem. Use an abstraction in another way because it might also apply. And so in looking at all of these visualization design models, we also looked at other models across other fields like design and human-computer interaction. And what we saw was that for these models for design, that there were sort of these 2 different camps. These process models here on the left, and then decision models on the right. where a process model characterizes the action that a designer takes as a series of steps, an example of which was the 9-stage framework. And then decision models, on the other side, to sort of characterize the rationale behind the decisions a visualization designer makes. And we found that there was really no explicit guidance to connect these actions that we take with the decisions that we make. And without this sort of bridge being able to link this, we might not have as justifiable of a design model. And additionally, looking again at some of these other fields, we saw that there's other process models beyond just this 9-stage framework. And this variety of models, there's sort of two different camps. The first of which is an engineering type process model. And these tend to be more heavy with a problem definition up front, very sequential, maybe cyclical in nature, and then they converge towards a single solution. But on the other side, we saw more of these creative process models. And these types of models have a more gradual problem scoping, where there might be overlapping activities, and they're often divergent until the end of the process. And what we saw was that these existing visualization models did not support some of these more flexible and creative aspects. And we wanted to incorporate these sort of flexible aspects of the design process and try and find a balance between these two types of models. And then lastly, existing methodologies for teaching visualization design have sort of varied across the years, and there's been some really interesting recent work. The first of which is visit cards, some work where they took these sort of card-based designs, you see here on the screen, and they employed them in design studios in the classroom, different class exercises, where they made design choices and promoted discovery. And they allowed students to sort of reinforce the concepts of what they'd learned, but then also gave them some prescriptive choices upon which to choose from. And so we wanted to take this idea and then also other types of ideas, like the 5 design sheet methodology, which provides worksheets that give very sort of outlined steps for a student to go through an ideation process, encouraging the divergent nature of design. And we wanted to incorporate both of these to help teach the design process in a way that is both discoverable for finding new types of methods, seeing what sorts of options you have at your disposal, as well as more actionable to help guide novices going through the visualization design process for possibly their first time. And so we combine many of these aspects in the multidisciplinary process models we've seen here to create the design activity framework. And the core of the framework is the concept of a design activity, which has 3 different things: so motivations, artifacts, and methods. And so each design activity was created to sort of address these 3 high-level questions, like where am I in the process? What is my goal? And then how do I get there? Where a motivation is sort of the specific purpose about like why you're performing that design activity. And artifacts are the results of that activity as well. And they're characterized by where they address different levels of the nested model, which is a decision model. And then we have methods, which are the actions or techniques that a visualization designer might employ to try and generate or evaluate those artifacts. And so this is kind of at a meta level, trying to explain what a design activity is. But we specifically identified 4 unique design activities that we perform for visualization design. And these 4 different activities are the understand, ideate, make, and deploy activities. And you'll see them throughout this talk represented with these different colors as well as a little symbol, U, I, M, or D. So we can describe each of these 4 activities using their motivation and visualization artifacts. So we're going to quickly identify each one of those for these 4 activities. So first, for the understand activity, we have a motivation, which is finding the needs of the user, figuring out what they want to see, what they're trying to look at in their data, or maybe what tasks they're trying to perform. Whereas ideate is about generating good ideas that sort of support those needs, that help them solve their problems. And for make, it's about concretizing those ideas, making them more tangible. And here it's about finding that detail, that tangibleness that might distinguish it from being more in the ideate activity. And then lastly, in deploy, we have a motivation of trying to bring a prototype into effective action in the real world, get it into the hands of the users. And so each of these motivations, while it's unique for the activity, what are we trying to achieve in each activity? And that's what the visualization artifacts provide. So for understand, we have a set of design requirements, things like design opportunities, constraints for your project, things you might want to incorporate in terms of the data and task abstraction. And then for ideate, it's creating sets of ideas. And these are often externalized in a variety of ways. They could be sketches or wireframes. And then for the make activity, we have sets of prototypes, where here we define a prototype as an approximation of a product along some dimension of interest. You often create these by developing code, but you can create them in other ways as well. And then lastly, in deploy, we have a visualization system that we've created. And that's sort of the end goal of what we're trying to do in visualization design, is create systems and tools and data visualizations that people can use in the real world. So now I'll show you some example visualization artifacts from this cybersecurity redesign project. So when we started this project, we did a variety of different things, but we were looking in the deploy activity because the company gave us this finalized tool and they wanted us to take a look and do an analysis of what was there. And here, when we did this, we started by doing a software analysis of their visualization tool. See like what types of tasks, what workflows were supported by the tool, how did they use data visualization currently in the tool. And this software analysis really kind of inspired us to take a step back on the design process, to look at maybe, do we have a good understanding of the problem? What are these analysts trying to perform? And to help with that, one of the methods that we used was doing qualitative coding, a method here to look at a variety of different papers and catalog that information. And so when we looked at this information, these are cognitive task analysis papers, which have provided a lot of really detailed information about analysts and their workflows in the cyberspace. And this gave some interesting information where we found design guidelines and found out their roles and different workflows that they performed. And so using this qualitative coding, we were able to target specific user needs, different design requirements that we prioritized. And then this also gave opportunities for our redesign project. And using those opportunities and all these requirements that we gathered and generated, that led us to the next phase, which was working in ideation, where we created different concept sketches and wireframes. Here we created a variety of different things to try and re-envision navigation in this main system so you could dig into the visualizations and get to the details of the data faster. And we included other things like being able to promote team collaboration so that they can communicate across different analysts what they found and why it might be interesting. And building upon these ideas, we then combine those ideation, all the different sketches we created together into a digital mock-up of the tool here. And here, this mock-up is more of a final detailed wireframe, a little bit more polished to sort of mimic a real-world tool. And that's why it's in the make activity. And it's starting to think about different types of data visualizations that we might want to incorporate in a real design, such as a timeline-based widget you see at the top to sort of select and focus your attention to certain parts of the data. And so we saw here that the design theory framework can represent these different visualization artifacts throughout the design process. But how do we now compare and validate and evaluate these different artifacts? And so we can do that by thinking about the nested model here again, looking at these 4 different levels. And specifically, we wanted to think, how can we capture this rationale again and record these decisions that we've made? And you can look at the design theory framework as sort of mapping into this model this way, where each of these columns here represents the activity, and then these little bubbles represent different artifacts and where they might overlap. And so they might overlap across multiple. So if we take a look at our example, like we had that qualitative coding in the understand activity up here, and when we did that, we created different design requirements. And some of those might affect things like our abstraction, because they might have been tasks the analysts want to perform. But other things might have been more domain-specific that might fall into a domain characterization. And so there's quite a bit of overlap here within this mapping to this decision model. And remember now that visualization artifacts are goals for the design process, but how do we achieve them? And we do that using design methods. And so by looking again at the design community, we saw a lot of different ways people categorize design, generally into, or design methods, into typically generative and evaluative methods. And here, generative methods are about being divergent and coming up with new types of ideas or solutions. And evaluative are more about filtering those outcomes to create a smaller set. And you might do that with domain expert feedback or performing a user study. And so evaluation here occurs throughout the design process, not in a single activity, but in any activity. But what methods map to which activities, and which ones are generative versus evaluative? And so we did some of this work for you. We actually created a table of 100 different design methods. So I'll zoom in here on some examples. And for this table, we looked at these design methods and thought, which activity do they exist in? Understand, ideate, make, and deploy. And then we mapped whether they were generative or evaluative within there as well, trying to help promote discovery of new design methods. And we tagged which ones we saw were sort of new and maybe potentially interesting, or that had been used, in the visualization community or not. And we included definitions for people to take these methods and try them on their own. And so now that we have these design methods to sort of generate and evaluate visualization artifacts, how do we track where we are in the process and where should we go to next? And so we built design process timelines to help capture the design flow. something that's flexible and supports the more messy nature of design. And so we provided structure through two different movement principles, the first of which is that forward movement is always ordered. Forward movement is always ordered. You go one ahead at a time. And then the second principle is that activities can be nested or conducted in parallel. And so to illustrate these principles and design flow, let's look at some real-world projects. So the first of which is the redesign project that I've been talking about. So we started in that deploy activity, and we took a step back and to understand. And there we created some sketches, and during that time we did some analyst interviews where we went back to the understand activity while we were sketching. And then we also created that final digital mock-up where inside of there we were going up with some ideation of new types of temporal visualizations. And then we also worked with a colleague to develop this timeline of their design study, where they were working on 3 different prototypes in parallel, and over time these 3 prototypes merged together into a single tool. And so this shows some of the parallel nature of design. And then lastly, we looked at another design study which had a very methodical description of their design process, where as they identified the sort of tool they wanted to create, they worked with users to understand their process, what their needs were, and then created that tool, deployed it, but then iterated on it over time to improve how that tool might be useful in the real world for their types of tasks and problems. And so we see that these design timelines are able to capture these very complex projects in a very rich and interesting way, sort of this parallel and nested nature of design. So in summary, the design activity framework has design activities with visualization artifacts. And then we've mapped those to nested model decisions for each of those artifacts. And we provided discoverable design methods for each activity. And then we also talked about how you can start to plan and communicate the design process using design timelines. So after formulating this design activity framework, we wanted to test it out in the real world. Is it something that you can actually use to perform visualization design? Can you track the artifacts, decisions, and methods that you've used? And is that useful? So in order to perform this validation, I've conducted a design study in cybersecurity. So continuing some of that work. And here we wanted to serve it to sort of validate the framework. Am I able to take this framework and use it in the real world? And I conducted a 2-year-long design study with folks from MIT and Lincoln Laboratory, different analysts and researchers there, where we were trying to create a dashboard for communicating cybersecurity information to different types of users. And so we wanted to track the different visualization artifacts we created throughout this process, as well as employ new types of user-centered design methods to find ways to overcome challenges within this space, like limited access to data and users. And then we also wanted to ask a simple question, like, can this lead to a successful design study? Are we able to evaluate with users and deploy in the end with the final tool? And so the first stage of this project was to look at the data and the tasks that analysts might want to perform. And here I present our data and task abstraction. The first of which is the concept of a network record, which is some metadata that is associated with communication between 2 computers. And specifically what we worked with analysts to study in this design study were alerts. And then from here, we can make collections of alerts called patterns that might represent some recurring or abnormal activity that's occurring on our computer network. And here, these patterns are something that analysts want to find to see if information is being disclosed when it shouldn't be, if there's theft, if there's denial of service, things that analysts really care about. And what they want to do with these patterns is they want to first discover them, but they also want to be able to present them to other types of users. One of the things that an analyst told us, for example, is like they use dashboards, and that's very important for them because, as an analyst said, pictures are great when going up to management because you often have 60 seconds or less to make your case. So it's really important to get a good overview of why there's a problem and how you detected it. And doing this, we use methods like aggregation and deviation to show some of this variation. So this abstraction and these tasks were identified from a methodical design process that we performed, which was informed and guided using the design activity framework. So for this design project, we had multiple different discourse channels. And you could think of them like having different organizations. So throughout our 2 years, we worked with the software company in that redesign project, which informed this design study, as well as a research organization, and worked with folks here at the U, as well as another organization. And throughout this process, I was embedded and worked with users throughout a variety of times. So we worked with some users, we worked with different sets of data over time, and we performed a variety of different design methods, things like qualitative coding, which I've talked about, and we did a variety of other design methods throughout the process. And this allowed us to create different tools, which were eventually deployed to the hands of users. And when we're thinking about this design process, we were able to track some of the connection between the methods and the tools and the deployments that we were able to perform. And so the design theory framework can be mapped into this model by looking at some of the different activities at a very high level, where we started with this understand activity, went through some ideation, and we often went back to revisit that understanding, to talk to users, to interview them, to understand if this met their needs or not. And we'll talk through some examples of this. But in the end, we were able to deploy to users in a variety of different ways. And in that way, the design tree framework helped guide and support this successfully deployed visualization tool. And it helped impact real users in their workflows. So next, I'll showcase two of the design methods we employed, specifically personas and data sketches. So for personas, we wanted to identify which users we should target for visualization design. We wanted to think about what levels of detail are they able to understand that we should show to them. And also communication for a dashboard is really a two-way street. You have to show it between one user and another type of user. And so we wanted to capture, through creating these personas, we captured a flow of information as it goes up this chain of command from cyber analysts up to a CEO of a company, and decisions which might cascade down. And this helped us because we were able to establish some potentially representative users and focus on them, specifically analysts and managers, so that we could look at certain types of data and the details that they might need to see. And with this focus, we were able to create an initial prototype for this dashboard, but we still had questions on what types of encodings we should use. And so the next method, data sketches, explores just that by looking at different types of encodings. And so this method allows you to find appropriate visual representations by looking at your data and getting them sketched in sort of a digital form as soon as possible. And we were able to perform this method by working with an analyst here at the U, and we got some data set of the network here at the University of Utah, and we provided these variety of sketches that look at some of that data, or look at other potential encodings that people have created in the field. And we got feedback from the analyst about what types of sketches were most promising for visualization design. And one of the things that really stood out from all these discussions that we had with the analyst was that there was this idea of a location-based map encoding, which was something that was quickly understandable and intuitive to the analyst, but also useful. There were some patterns that he saw in his data that he didn't expect, that he didn't know about, even though he looks at this data every day in his job. And so after identifying this new encoding, we redesigned our first prototype to create the BubbleNet dashboard. And so this dashboard provides information at a glance, the first view of which is a location-based view. It uses a Dorling-based cartogram, where here the size of each bubble represents a country and how many alerts have occurred for that country. And then the number of records in that deviation is recorded in terms of like red is higher alerts than average and blue is fewer. In addition, we included a lot of linked views, such as a heat map encoding to show by day and by hour where alerts have occurred over time, as well as attribute views, so you can show in sort of a bar chart view how, what's the priority level of those alerts and the category of those alerts. In addition to keeping track of the details of all the information, so an analyst can look up in their raw data the details of an attack or what might be an interesting pattern they found, as well as a selection overview. And so there's a lot of interaction that occurs within this dashboard that really adds another dimension of information. And so I'll show some examples of that through this brief video here. Whereas you can create different ways, you can pivot on the data in different ways. As you hover over different countries, you'll see it updates the variety of different views that we have in our dashboard. And you can also hover over any of the time slices that we have over hours and days to see it update the map and all the other views as well. And similarly, when we move up to the top, you'll see how it interacts with all of the different bar chart attribute views that we have as well and updates all the views accordingly. And so we found that when showing this to users was that they were able to find patterns, things like peak traffic in the network and dead spots and waves of alerts, and even some interesting scripting behavior that was occurring that they did not expect to see in the data. And these sorts of patterns and things we found because and these are useful and domain relevant patterns, and we discovered these during actually a user study that we performed. And so for this user study, we worked with 9 different users, performed an hour-long think aloud scenario and a questionnaire looking at the usability of the dashboard. And this shows the results of that usability survey, 10 different questions. And overall, the mean that we got from the users is 75. Aside from the really harsh analyst, we did pretty well. And And the mean here, 75, is like a moderately usable system. So it was pretty good overall and could be improved, but there's always ways to improve that. And what we found, though, was more interesting, was really working with the qualitative feedback from these users as they talked about what was useful in the dashboard. Things like one of the analysts even told us our abstraction, saying the majority of what we were looking for is patterns. And this dashboard just makes patterns, which is faster. And in addition, one user said it's very responsive and dynamic. Some of the interactions you saw were sort of hover over techniques, so it peeked into the data really simply. And then lastly, one analyst said, like, I could write a query to do this, but this dashboard is just easier. And sometimes that's what data visualization design and creating tools is about taking a problem that's really difficult and just making it a lot easier for someone so they don't have to sit there for hours to solve a problem. They can just open up your tool and they get the answer right away. So in summary of this project, we conducted a successful design study. So we not only evaluated this with users, but we deployed it in with real-time data in a research network operations center. In addition, ideas were incorporated into a dashboard creation tool as well. Ideas such as this flat map and linked-based visualization views. And throughout this process, we were really heavily guided, and the design theory framework helped shape this project. When we performed different user-centered design methods, recording our visualization artifacts, it really helped. Like qualitatively, what I would say is like the design theory framework was able to capture this very rich nature of the design process. And it allowed us to communicate the project more succinctly, but completely, using things like a design timeline. Yeah, the figure we're looking at here is one of those tool deployments. This is an example of that dashboard creation tool that they created using some of that inspiration from the BubbleNet dashboard. So that was a separate tool that was inspired by and deployed using those ideas. Does that address your question? Okay, and in case, make sure that's on record, the question was what the image on the screen was. And so this design study was an internal validation of the framework, but can other visualization designers actually use this framework? Is it something that could be used in the real world for other types of people besides myself? And so to do this, we decided to turn to creating worksheets and evaluate them to perform an external validation. So we wanted to create worksheets that would first increase the actionability by providing concrete steps for the design process. And we also we worked with students to help understand, what does a novice visualization designer face in a visualization design project? And how can you help them in a cumulative class project to perform the design? And then, the question we had is, can novices really follow the framework? Are we able to provide them enough materials to do so? And so an example of one of the sheets we created here is like an introduction to the framework to sort of explain what the design theory framework is about and provide some examples. And we needed to actually create worksheets, though, for students to actually follow. And so here, we identified 5 different steps. I'll show first here the understand worksheet. And these 5 steps were built from our collective experience in visualization design, from how we've performed projects in the past, what types of questions we've asked ourselves, as well as looking at existing worksheets coming from the architecture department to sort of inspire how we perform visualization design and what steps we've taken. And so we identified 4 different generative sort of methods or steps, if you will, in the top 4 boxes there. And then the 5th and final step was an evaluative step, where we guided students through each one of these phases and provided hints and little tips throughout the worksheet. So in addition to each of these 4 worksheets that we created, we also identified that sort of introduction to the framework, some tips on sketching, as well as sample artifacts and worksheets using that design study that I mentioned previously, the BubbleNet project. How we went and created that project, we kind of showed an illustration of that throughout the design theory framework. And so to test these worksheets, I taught them in the graduate student data visualization course here at the University of Utah with 60 different students, and I showed them the design theory framework, walked through this sort of process of visualization design in a lecture, as well as showed the nested model and examples, again, using that dashboard project to sort of inspire them and to show them different types of visualization artifacts and methods you can employ. And then we gave them the worksheets at the end to sort of allow them to use them in their projects. But more specifically, we recruited different volunteers, 13 different students across 6 different project groups. As they performed a cumulative project for the end of the course, we helped them use these worksheets in their own projects. And so we, had weekly progress meetings with each of these groups, where mainly they would just kind of go through some of these worksheets, show us where they were, what artifacts they'd created, where they were in the process. And then I also answered several different questions that they had. Some of them were about the worksheets, and some of them were more about visualization design, like having questions about which sort of design should I choose. And so this mentorship does provide some interesting aspects of the project as well. And so at the end of the course, I conducted an evaluation of these worksheets in addition to the observations I made throughout the course. And overall, it seemed like the design worksheets were able to help students learn. So we conducted a course survey where we gave to the entire class, as well as individual interviews with a variety of the students. And we found that generally they were able to use the worksheets and go through the design process. And there were some interesting insights we gathered when looking at all the different information we'd gathered from the interviews, where some of the examples were that a lot of students found some of the worksheets most helpful. Things like the understand and ideate worksheet were the ones that they really enjoyed using. And one of the reasons is because they both kind of helped get the project off the ground. Because getting going when you first start a project can be really challenging, knowing what types of data you have, what aspects of the data are interesting to users, and what tasks you should perform. And in addition to that, another student also said like the critiquing one's own design is really helpful. By going through this design process, by thinking divergently, but also really thinking critically about those designs is really helpful for them to perform. And then they also found that throughout this project, this allowed students to kind of focus, to keep producing artifacts over time. And it might have helped having progress meetings, so they would always have to produce something. But rather than throwing everything and procrastinating until the end of the course, they were able to keep going through their design process. And a lot of the students created some really interesting designs that evolved over time. And then these worksheets also helped provided a snapshot in time. So when students had to write a process book at the end of the course, they could look back at the worksheets and really easily reference some of the artifacts they'd created. And so we saw a lot of students mention that. That was a useful aspect. And then lastly, we saw that sort of providing these different steps on these worksheets were very useful for students because it's like a checklist to make sure everything's covered. And while these aren't necessarily wholly complete, but having that checklist was a good way to get started. It allowed students to sort of break the ground on some new project. And rather than just being stuck with a blank page, you have some content there. And the only other thing we saw was that some students would have appreciated some more information as well. They might have, or less information, I should say. Like they didn't like the boxed nature of the worksheets. They would have preferred just that checklist of items so that they could go and take their own worksheets and sketch them on a blank piece of paper and do with what they will. And so this sort of difference in students, we saw some students appreciate having these boxed worksheets and some that really would have appreciated just a checklist. And there were a lot of other interesting improvements we found that the students provided to how we could improve the worksheets in the future. So after creating these worksheets, we saw that while this was sort of our first iteration on them, we found that it made the design theory framework a lot more tangible and actionable and useful for teaching visualization design. And so next, the last part of this dissertation is that we reflected on what the design theory framework means for other types of research, going beyond just problem-driven visualization design. And so again, thinking about what other types of research can we perform besides design study styles of work. And so specifically, I performed research in 2 different projects looking at technique development as well as performing evaluation methods. And I had questions like, what role does design play in these other types of research? And does the design theory framework lead to different ruminations, sort of insights, things that might be novel, useful, and intriguing about the design process? So for example, in technique-driven research, we created the S-score plot, which was a way to encode correlation in a scatter plot. And so the way correlation you might normally think of works is like you have a scatter plot, a bunch of different points, and then you get a correlation coefficient. And what this plot does is it encodes those coefficients directly using a scatter plot. And so if we take some point P and some other point S, we can look at the correlation of any point to point P, and its correlation coefficient is just along these vertical grid lines here, where X here would be about like a 0.6 correlation. Then you could have all the way down to -1, and then points close to P would be 1. And we can define a projection by using point S to create the secondary grid line, where now we can see it's maybe about like -0.35 correlation from X to S. And so using these correlation coefficients in this projection, we can now encode a lot of data into a single plot and encode additional attributes with color. And so that's what the S-score plot allows. But interaction supports a whole nother way to explore this multidimensional correlation space. So I'll show some interactions here that you can perform in this tool where you can select points, and then when you click on those points, it'll reorient this projection space. So you can look at the data and the correlation coefficients in a new way. And there are a variety of other things that we adapted into this tool, looking at like a parallel coordinates view in the top right, or principal components so you can explore the space in the top left. And so these are different ways you can look at this large, high-dimensional space. But we created this tool for biologists to actually study their data. So while this seems very generic, you can use it for specific use cases. But while we were performing this design study, trying to help these biologists look at their data, we hit some snags during that project. And so when reflecting on the design theory framework, we were able to come up with some new ideas about maybe why we hit those snags and how we could have maybe overcome them. And so for the design theory framework, when thinking about this tool we created and the problem that the biologists faced, is that we sort of had this incomplete problem. Where while the biologists were able to use our tool to look at their data, to answer some interesting questions, they also just found that they had more questions as a result of using the tool. They really needed a lot more data to use within our tool to make it more useful for them. And so in addition to working with that, we also found that there were new pitfalls that we kind of fell into that you might, when you're performing a design study, things that you might want to avoid when you're going through this project for yourself. And some of these pitfalls included things like team miscommunication about what our abstractions were and what our design requirements were, really understanding what the users were trying to achieve. That wasn't really communicated clearly across the team, partially because we didn't have all the team members following this same design process model. In addition, we prioritized this novel idea, this S-core plot, over what the biologists were actually trying to perform trying to understand with their data. And then lastly, we deployed too early. We gave this tool to them and they wanted us to just improve that tool, to kind of develop it over time, add new features, and that ended up limiting what we could do. And then lastly, thinking about this sort of technique-driven process, when we created this, we went through a lot of the similar design phases as we went through, come up with these ideas, came up with different encodings. But what's interesting is algorithmic decisions occurred a lot earlier. As you go through and understand maybe the problem domain, it might be mathematics or statistics. And so these algorithmic decisions can come up a lot earlier, as you might come up with an idea that relates to maybe improving the speed of how you might actually create an encoding. So next, what does evaluation research mean for the design process? So for this, we studied visual data-driven stories. And we wanted to study how readers navigate different stories. So you'll see, as a reader performs some input, in this case here, we have some scrolling input on the screen. So as we scroll, we see that the story dynamically updates what animated transitions are occurring. And we took this sort of scroller version of the story and we adapted it into more of a stepper style, where as you click a button, you'll see that the animations just play discretely. And we wanted to understand, do these different types of narrative flow affect how people engage with a story? So we took these two conditions and we also created a text-only version of the story and one that had no animations, that just used static visuals. And which again is more engaging of these four conditions. So to measure this, we conducted a crowdsourced evaluation where we used 240 participants on Amazon Turk, Mechanical Turk, and we asked 14 different questions. We compared two of these, each participant compared two different conditions at a time. And on this, they answered a survey on engagement where there were 14 different questions, asking things like, did you find this, which part of the story was more fun, or were you more absorbed in, which one frustrated you, and which one was maybe more visually appealing. And so based on these results, we were able to map a model of the different engagement scores that we calculated for the text version of the story, the visual, the stepper, and the scroller versions. And what we saw was that sort of this visual, and especially the animated transitions, were significantly more effective in terms of increasing engagement. And additionally, we saw that the preferences were also very much in favor of these sort of animated transitions used in the stories that were linked to navigation. And so upon reflecting on this research with the design theory framework, we noted that things like the hypotheses that we generated and the story prototypes that you saw, creating the stepper version that we did ourselves, those are visualization artifacts that you create during the design process. And that some of the methods that we performed, things like pilots and exploratory studies, were very similar in that they were trying to take those visualization artifacts, test their usability, and improve them over time. And that with regard to experimental design, it's very important to record these details, to sort of measure the reproducibility, so that when you give this results to someone, they can actually reproduce what you've done and see if what you generated was true, or if it holds. And then lastly, some of the guidelines that we established lack a level of generalizability to other types of stories and data visualizations. So thinking about the design theory framework allowed us to sort of again, see this lack of generalizability by mapping it back to the nested model using the different artifacts we created. So the design tree framework provided a variety of novel insights as a lens into some of these projects that I've shown here. But the framework, as with many design models, is a work in progress. So design models might need to change and adapt and grow over time, as you might find potential with new types of activities that might show up, or methods that you want to employ, or artifacts that you might need to create. And then decisions. There might be new types of models that come out that you want to incorporate in your design models. Additionally, you might want to think about how you can continue to evaluate design models, like such as these worksheets that we've shown here, using them in the classroom and maybe in other types of scenarios as well, using them in design studios and exercises, maybe incorporating other types of educational pedagogical materials like visit cards and 5 design sheet methodology. And then lastly, also thinking about how we can apply to other models of research, other modes of research, like I've shown technique and evaluation-driven research, but how can we map this model more effectively to those types of processes? And then lastly, what are other types of processes that we might want to incorporate in the design process? Thinking like software engineering process models, specifically agile methods, which are designed to adapt to user needs in a changing workplace. There's a lot of overlap with how that might correlate with visualization design processes. So in conclusion, I've discussed the primary contribution here of my dissertation, the design theory framework, which provides things like visualization artifacts, mapping to decision models through the nested model, a table of discoverable design methods, timelines to support mapping and communicating the flexible nature of design, and design worksheets to help make it more actionable and to teach the framework. And so we validated the design theory framework using a design study. And then we evaluated worksheets with students to sort of perform an external validation. And then lastly, we reflected on how other types of research connect with the design theory framework to the design process. So as the field of data visualization design matures, it is crucial that we adapt and modify our design models in order to better prescribe, describe, modify, encompass, analyze, and communicate the rich and multifaceted nature of the visualization design process. So next, I would just like to briefly thank the many people without whom I wouldn't be presenting all this work here today. The members of my committee, Mariah, Alex, Tammy, Jim, and Natalie, as well as my many family, friends, and mentors that I've had over the years that have helped shape who I am to be where I am today. And a lot of the SKI and School of Computing staff who helped make this possible and helped make this as smooth as possible. Folks like Brenda and Deb and Christine and Ed and Robert. And then all of my co-authors across our many publications. Some of those you'll see here listed on the screen. And with that, I would just like to thank you all for your time and for listening.
Okay, so this is the point we open it up for questions from the audience.
Yeah, and if we could just make sure we use those mics, or else I'll repeat.
Yeah, it's a little
your
cumbersome, but
questions
just try
as we
to
go forward.
pass these around. Okay, I will start it off then. So you're getting ready to move on to a job in industry. And I was just wondering, do you anticipate actually using the design activity framework in this new position you're going to be in? And if so, how? And if not, why not?
Yeah, all right, thanks very much for the question, Mariah. So in terms of using the design theory framework in the future and applying it in industry, that's something I'm really interested about, to see like what role does the design process play for different software engineering models, something that I mentioned at the end. So Lucid Software, which I'll be joining in the fall, they perform an agile type methodology where they iterate very quickly. They have like 2-week-long deadlines. And I'm interested to see like what role does design play throughout that process. And they have like in-house designers that work on coming up with new concepts. So I'm really hoping to do some collaboration and work with different folks and see how we can go and do that process. It'll be interesting. I'm not sure how much experience they've had in doing visualization design, so to speak. So there might be some interesting connections about how you can maybe use this model more generally, or if it's actually useful for other people. But I'm really interested to see if that's the case, and if so, how we could explore that. Because I definitely don't want to just have this be it and done. I would love to keep iterating on these concepts. And there's certain aspects of this model that might be useful for design generally, and that might be useful for other types of processes, as we mentioned, like a software engineering process. And thinking about how you can more capture and prescribe and describe aspects of like coding and development might be interesting, but it'll also be like folks there, if you're working with engineers, they are typically more experienced. They have some knowledge of that process, whereas like in the visualization design course, it was very different. Like we had some students who had like almost never done any formal coding before in the class. So depending on experience and who you're working with, like designers might not know much about coding. They might, but so there could be very interesting sort of different focuses based on that. But does that answer your question?
Okay, so I really like your worksheets, and I was wondering, you were framing them mainly as a tool for novices that don't really know, like they wouldn't read an academic paper about the design activity framework. Could you speculate a little bit? Do you think those worksheets are also helpful for somebody versed in the design activity framework? Would you, for example, yourself use them when you do such a design project in the future?
Yeah, excellent question, Alex. I think that when I designed the worksheets, I tried to make them like questions and steps that I've answered in projects, so I could imagine using them. The challenges might be like you might, again, feel kind of boxed in depending if you're more experienced in visualization design. You might prefer having more space to write a sketch. Like actually creating a data visualization in this tiny little box was very frustrating to a number of the students. So I could imagine taking the concepts of these worksheets and maybe reapplying it in a different form and using that in the future. There might be another thing that we didn't explore with the worksheets was actually like these steps are very detailed and like they might tell you a certain way to evaluate your ideas, but there's many other design methods out there. So I would hope that a visualization designer might take these worksheets and maybe replace a box with some other design method that they want to employ, or use a design method to like go through the understand activity, but don't just do it once. So I think there's a lot of potential there, but we haven't explored those, so it would just be kind of speculation to say whether they could be useful, but I would hope that it could be, because that's how we designed it, to be generally useful for other types of people. And some of the folks who worked within the class did know a little bit about the framework too. Some of the folks were here in our lab, so they've had some experience and exposure to the framework before they used the worksheets and saw it in the class. Yeah.
So this follows up with kind of both questions and particularly like the agile software development. Where do you situate this work as far as being theoretical or totally practical? Because agile is primarily a practical way to work through problems very quickly and communicate things, versus some of the other design approaches that you talked about, which were much more theoretical. And I'm wondering where you would situate this, and does it bridge both, or is it primarily on pragmatic?
Yeah, it's an excellent question. And I think that kind of like when we originally created the design theory framework, some of our inspiration was like looking at these theoretical models to provide a basis, but then also trying to make it more practical, to make it more actionable, if you will, like trying to have simple definitions and simple achievable artifacts and things like that. And when we created the design theory worksheets, we were thinking definitely with that more practical, I think, mindset, like providing people ways to go and perform the visualization design process. Like, a more theoretical thing would probably be much more all-encompassing and much more flexible without forcing you into these specific steps. But the more practical approach is to just give them steps that they can follow. And then our hope is to maybe try and bridge those two so that at some point you can use in practice the practical steps you've taken and extend them to maybe other types of models, looking then at the theory, like kind of a way to get you into the design process to start to understand it, and then maybe take further steps into more of that theory-driven stuff, if it's useful. I mean, it depends on who you are and what you study. And I think that there's a lot of interesting aspects we've seen on the theoretical side too. Does that answer your question?
Yeah.
Thanks.
I have a question, actually.
Yeah.
Can you hear me now?
Yeah, we can, Natalie. Go right ahead.
Okay, just wanted to make sure. Thanks for the presentation. It was very pretty and very clear. I'm a big fan of your new lens on the design process. Continuing a little bit about the framing of your work, I was wondering what's kind of really specific to visualization compared to more general interface design. Can you just help us understand a little bit there what's specific, or if it could be applied to any design of new interfaces for users, basically.
Yeah, definitely. Thanks so much for the question, Natalie. So for the design theory framework, we targeted visualization design. And some of the components that we've talked about were focused kind of specific to that. Things like mapping to design decisions using the nested model. That is very much a visualization design model. There's many other types of decision models out there, and I think to take this more broadly, you'd have to think about some of those models. And there's a lot of interesting future work there. In addition, we also focused our discussion, like listing achievable artifacts and descriptions of the design process, towards things you might care about for visualization design. So design more generally might have other things you consider about, and we did some of that stuff with the redesign project, but a lot of our other projects since then have focused more specifically to visualization design. And that sort of validation and the evaluation of the framework was all in visualization design projects. So I can't really speak to whether this would apply generally or whether you could sort of validate it in that way. I think a lot of it, speculating, could apply generally. Things like these activities might be useful, but I think it would require a lot further like discussion, thought, as well as validation to see if that's the case. Does that address your question, Natalie?
Yes, thank you.
Yes, thank you. And it's red back there. If you could. Okay, thanks.
All right. So to follow up on that question, what is it about the visualization design space? What's unique about that? What are some of the unique challenges about working with visualization design?
Okay, so what sort of are unique challenges when it comes to designing visualizations in particular, correct? Yeah, so I think when it comes to like data visualization design, there's some of these design aspects, like you have designers creating data visualizations. Some people call them infographics. I mean, there's a lot of people in a variety, like in a spectrum really along the space. But on like more of the data visualization side, we have people tend to be more grounded in taking your data and developing solutions for that. And so that sort of programming, that software engineering aspect that gets built into the process, I think is where it starts to become sort of a mix of the two areas, where you sort of have design and you have software engineering. And it's kind of the mixture of the two as you create these data visualizations. Like you keep an eye out in front of a variety of different things. So visualization design, like on the one hand, it's looking how you encode data. But on the other hand, it's also for humans. So we look at like perception of data, how people, or perception of like more visual encodings and things. Like, why you should choose certain colors over other ones, or why you should pick this encoding over that encoding. And so some of those perceptual principles are also something that's a little bit more unique to data visualization design as well. Does that address your question? Okay.
Can I ask further? Because when you gave the first few slides of talking about data visualization, which I thought was a good introduction, but from the outside, not necessarily understanding the nuances between data analytics, data visualization, right? There are a bunch of different communities that have tried to carve out a particular territory.
Yeah.
From the outside, I had the same thought of, it seems that this could just be used for human interfaces that are trying to solve problems for humans. And I was wondering the same thing, like, are there some unique characteristics that are focused with this design activity framework that only apply to visualization, regardless of the evaluation techniques or where you focus that? And or can it be generalized to this broader set of things, again, to step back from the nuanced descriptions and carving out of particular scientific fields and where they publish, to talk about a design activity theory?
Right, yeah. I mean, I would definitely concur that it's something that you maybe could apply broadly, that there could be connections, but that requires, I think, a lot further research, further like review of different models. Like we looked at some design models, but there's a lot out there. And when it comes to the visualization specific aspects that this model kind of addresses, some of those might be like, when I think about like what we created with the worksheets, like some of the boxes were specific to like finding, like looking at your data, exploring the data, finding certain aspects. And some of that might apply to other user interfaces that incorporate data, but often if you're showing data in some visual way, you can argue that's a visualization. Some people even say showing tables in a way can be visualizations, because then you can incorporate visual encodings inside of that table. With some of the work I know Alex has done, they've done some of that work by sort of meshing those two worlds of like just data analytics versus data visualizations. So I think that's really that aspect of data, that core like understanding of how people look at their data, what tasks they want to perform, and then the perceptual principles that affect how you look at that data. Because there are perceptual principles and sort of cognitive theories about user interfaces, but I think there's also some of that which is extended but also different when it comes to visualization design that might apply.
And so some of that description that you just gave right there at the end may factor into why certain methods versus others, right? Because it is about this understanding of the presentation and making sense of visual stimuli that represents data behind it.
Right.
Is that right?
Yeah, I think that's one aspect. And the other thing that I didn't mention yet too was thinking about sort of these later stages of the design process, like things like when you're building prototypes and deploying them. Like some of that also gets into software engineering, and that's where sort of it kind of sits because we're trying to like bridge these multiple domains, if you will. Like if you think about design, if you think about software engineering, these different processes, the design theory framework is sort of trying to sit somewhere in the middle to try and get, again, that theoretical basis, but then also very practical aspects that it lists as well. So that's where, again, it might not apply as broadly because not all designers are going to want to code, or they might not know how to code. They might work with developers that do that too. So there might even just be different teams that might use different aspects of this, or that might correlate to different parts of their process.
I have one more question.
Yes.
The thing I really like about this work is the fact that you've kind of formalized things that a lot of us kind of just naturally do. So I was thinking further along these lines when I was reading your dissertation yesterday night. And I just thought perhaps one more thing we do, perhaps that's not quite captured in your framework there, is all of the pitfalls that can happen at every single step. You know, for like one that just come to mind is that you start sketching your ideas in your ideate phase, but then you don't really use the people's data. So, you know, your sketching look awesome, but when you actually start getting the data from, you know, that will be used, it just is useless. Mm-hmm. So I wonder if there is some, you know, if you have thought about incorporating some of those pitfalls and like how.
Yeah, it's a very good question, Natalie. I know in terms of like pitfalls, a lot of what I've looked at in sort of the visualization design space has been from the design study methodology paper. So the 9-stage framework that I showed earlier, that comes from the design study methodology paper. And so they identified, was it like 30-some pitfalls across different design studies that they've fallen into. And I think because of that's also problem-driven work, some of that could map very well into the design theory framework. We haven't gone and done that specifically, but as you mentioned, there's some of those steps where you might do that. And so like if you think about what you were mentioning, Natalie, this ideate worksheet, when you're coming up with these, you know, different ideas you have, you know, the whole goal of the ideate is to generate those ideas to support some user needs. And so like, you know, if that requires knowing your data, if you haven't looked at your data yet, those ideas might be moot if you haven't actually thought about what the data looks like. That's where things like data sketches can be kind of helpful for that process. That's why we use those in that one design study. So like, I think that's definitely something that would be future work in identifying some of these guidelines or pitfalls to sort of watch out for in the design process. But does that address your question, or was there something I didn't
get to? I mean, I think just fleshing out some of those steps, perhaps, like, you know, ideating, and then somehow think about perhaps like requirements, like you need to have collected a set of data before you ideate or something. I mean, I don't really know. I just feel like those are kind of missing some guidance right now, and so that's kind of the thing I was thinking about. But anyway, thank you. It does answer my question. I'm not quite awake.
No worries. I think like the other thing is that the whole design process, like these activities kind of need to flow into each other, and it's easy to jump ahead without formally going through an activity. So an example of that might be like when you're building a prototype, while you're developing some encoding, you might have a new idea that sprouts up. Like, you know, what if I can maybe tweak this layout algorithm so it's a little bit more efficient in terms of the space, or that it's a little bit more readable to users. So you might go through and just code that, but you might not actually step back and see, does this actually address the user need? Or have we thought about other types of ideas and evaluated them? So you can easily skip to this process informally, but you might fall into pitfalls when you do so.
Actually, that leads me to a follow-up question. I don't know if people raise their hand. They're probably very frustrated by me right now, but you know.
No, you're fine. You're fine.
So I was wondering about this, you mentioned you have like those 4 sheets and then you show them to students. I mean, they're kind of used it. I was just wondering is there any guidance to kind of switch to the next one and then perhaps guidance to actually go back? Because I see your processes are, a lot of iteration between them. So is there any guidance to kind of when you're ready to go to the next step or to actually revisit a previous step? And then did you actually see students do some of that?
Yeah, that's a great question, Natalie. I know when it came to students using the worksheets, we required them to do the worksheets. So they pretty much just did one and done, more or less. Like they just tried to do their understand worksheet. There were a few students that did go back and revisit a worksheet multiple times, or when they were creating ideas, they would create like maybe one type of encoding view that they wanted. They would come up with one worksheet just for that view. But generally, a lot of students went through it fairly linearly. And I wasn't trying to push them. I was trying to see what did they do when given these worksheets. I wasn't trying to force them into thinking about it more broadly. But that's something that is, I think, kind of challenging, especially for maybe more CS students who maybe think more linearly, or it's easier just to do the assignment because that's all you have to do. But that's definitely something that, like, when it comes to the worksheets, we provided like some guidance, little hints at the bottom of where you could continue next. So like on the understand worksheet, you could revisit that worksheet, or you could jump to the next activity. And so later activities just have more options, and that can be challenging, and you have to kind of ask questions and think about what motivation. Like, think based on like your previous artifacts, are they good enough? Have you evaluated them, or has something else popped up? Have you developed a new understanding when talking with users that you need to revisit that understand worksheet? So that's sort of like the general guidance that I would have, but it's hard to really prescribe it exactly because it's really, some of it can be really project specific as well.
All right, thanks.
Yeah.
Okay. I'm curious about the potential utility of the timelines. I understand in general, but also from your last explanation, kind of the non-specific sequence of the design activities. And I'm curious how the timelines can be informative about this process and if you notice patterns.
Interesting. Yeah, it's an interesting question. Thanks. So when it comes to the timelines, I think that those are something that we found them really helpful when trying to communicate the design process. And we didn't formally use it for this, but there's been a variety of folks that I've talked to that have thought that these sort of timelines could be really useful for planning your design process, maybe reflecting like where you are, where you plan to go next. Sort of when it comes to like looking at project deadlines, trying to see where you need to be, and then work backwards from there. And additionally, in terms of like looking at these timelines, they could also help you communicate. I think I mentioned that. Sorry, did I address your question, or have I missed something already? I'm trying to make sure I'm doing this correctly.
Yeah, I think you're on the right track. Yeah, so you commented that they can help with planning ahead a little bit. Yeah, I guess I'm curious because you showed several examples of timelines, and they illustrate very clearly this non-sequential, non-linear order. And so I guess I'm curious, on a bigger scale, with the studies that you've done with the class, for example, did you notice patterns? Or is it really just kind of random and an assortment of activities throughout the process?
Yeah, I mean, I would say that it's not necessarily random. People choose how they represent this information in some way. So there's some decisions that get made about when you're focusing on a specific design activity when you're going through the process. And some of it might be less formal than other times. Like, it's like when our first redesign project, it was very retrospective how we sort of identified what the activities were. We used it more as a way to communicate that process rather than to think as we were conducting it or working with our design team to figure out where we were. And during the BubbleNet design study, like I showed you like a very brief overview of a very sequential type sort of overview of the design process. And I did that because like it was 2 years and there was a lot of iteration in different cycles that showing the details of that, like I didn't catalog it to that fine of detail. And it also might just be like overwhelming to look at it in that level of detail. And there are also, because there's multiple people involved in a project, they might be going through different design activities at different stages of the process. So some of the research work I've done has been more me doing development, me doing some of that design, but occasionally I've had collaborators where we work in different ways. And so you can also capture some of those with different parallel tracks, if you will, to see, is this designer working, are they working on building prototypes, wireframes, mock-ups, or are they interviewing users at this time? And so some of that you can track across the project. And as far as different patterns go, like some of the things, the patterns I guess I've looked at and created would be things like looking at this parallel nature, either when like you're working with, again, in those design teams, or if you're maybe creating multiple different parallel prototypes like we saw with Ethan's design study. And then other things that I've seen is when you're inside of an activity, maybe jumping backwards to explore a new concept or a new idea to sort of iterate on that, or to talk with users. That's something that's kind of I've seen common as well. But how you use those could be up to you. I would say there's infinitely many possibilities when it comes to how you might create these and do this in a design project.
Oh, go
Yeah,
ahead
Tammy.
with one. So in your dissertation, there was a mention of students doing some of the process with the worksheets digitally, particularly the sketching.
Yeah.
I don't know how much you have thought about converting the worksheets or other aspects of the design activity framework into an online or electronic version, but what would be some of the advantages of that kind of a format, and what changes or additions do you think you would need to make to general functionality to fully sort of take advantage of the digital format?
Right. Yeah, so thanks, Amy, for the question. Just to reiterate for those students who haven't probably actually seen my dissertation, what we saw was that during the working with students during the design process, there were some students that, one of the students in particular actually took the design worksheets, put them on their iPad, and then she just kind of zoomed into these little boxes to actually have, you know, a full screen to be able to sketch some of her different data visualization ideas. And she found that very useful and helpful to do that. And when it comes to like different design research, there's kind of a mixed response in terms of like whether digital is good or bad. Like some of the benefits that you could have by going digital is maybe someone could actually import their data, and then they could pick from some encodings and then see what it actually looks like in terms of a data sketch. So that could be really helpful, but it might also be limiting because then the ways that they look at their data, you have to give them like only so many different encodings to look at. So they might not come up with new ideas or think of different ways to look at their data if there aren't many options to choose from. And there's also just new things out there that they can't explore unless they write code to develop it. So that's some of the benefits, I think, of looking at sort of the digital version. And some of it's convenience. Like some people prefer digital things. One of the students actually, Cameron here, used like a notebook sort of on the computer to kind of keep track of all the details and used the paper worksheets to sort of summarize all of that information, which can be useful, I think, to have sort of succinct summary of what you've gleaned and gathered and understood over time and what sketches you've come up with. So I think the paper versions, though, do encourage different types of thinking, and sketching especially can, you know, kind of make you think in different ways and might make you create something that you wouldn't have done if you'd used a digital product. And I know that there's some benefits, though, when it comes to some of these digital interfaces, because you can do things like zooming, you can have an infinite canvas, and that you can use built-in shapes. And some students might be more comfortable starting than putting an initial pen to an empty piece of paper can be really difficult. Starting with an empty piece of paper is challenging for almost any designer, I think, unless they're maybe amazing designers. But for me, it's still challenging. So yeah, and does that address your question, though, on some of the different trade-offs?
It does, but I have a follow-up question. So I think in some of the boxes early on in Understand, it asks something to the effect of, and I could be wrong, what do your users want, or go talk to some users, or something like that. I was wondering if you'd thought about, for example, doing a walkthrough of, or sort of a decision tree of some of the methods that you highlighted earlier in a table to see sort of what are you trying to do, what are some appropriate methods to try to do that, here are some options, or if that would be something you would shy away from doing because it is less, actionable for novice designers?
Right, yeah, it's a great question. That was something when we created the worksheets we were kind of toying with. I think actually in the deploy worksheet, there's actually, because in this student project, we were not expecting students to actually deploy their system, create and be able to evaluate completely with users. So the last step here in deploy evaluation was actually more about, how might you evaluate it? So it was kind of open-ended to allow students to look at design methods. And you could actually take that table of different design methods that are generative and evaluative and look at your different options based on which worksheet you're on. So that's totally doable in the current form. The only thing that is it didn't map to those 4 different steps we outlined specifically. And there might be other steps too that we haven't outlined here that might be important for the design process, for creating visualizations. Like this was just one way of doing it, but there's many other ways you could step through that process. So I think that there could be some utility to that, but one of the reasons we didn't provide like a list of options for students to perform is because we wanted to make it more actionable, more practical in the sense that they wouldn't have to make many decisions about what they should do in the design process. Rather, they could focus their decisions on that process itself. So as they went through and created these sketches, found talked to users or looked at their data, found different design requirements, and then they could use that sort of decision power to evaluate those different requirements, to find which ones to prioritize and see which ideas were the best. So that's, I think, the reason why we decided to sort of simplify that. But it would be possible to extend.